โอเคค่ะเราถึงเวลาเที่ยงครึ่งแล้วนะคะ Sean I will pass this to you so you can start the presentation
Okay, so welcome. My name's Sean Maynard, and I'm going to be presenting on digital and IT careers and understanding the range of opportunities that you've got at studying in the University of Melbourne around in the IT space and the digital space. So the agenda today, we're going to look at 4 areas. We'll tell you a little bit about the faculty, our rankings, course, accreditation and that sort of stuff. We'll have a little bit of a look at the IT employment landscape. And then we'll look at how you can study with us and what you can study with us. And in that, we're going to try and differentiate between the different types of IT courses that we have. And then there should be time for some questions. Please feel free to put questions in the chat as we're going through, but hold any other questions until the end when we have some time for the formal questions. Okay. So with us today as well is Danielle from University of Melbourne is going to also help me in the chat answering questions, hopefully. So who am I? So my name's Sean Maynard. I'm an associate professor in the School of Computing and Information Systems. I'm also the Associate Dean Academic in the Faculty of Engineering and IT. I've been at the University of Melbourne for too long, for 28 years, and I've managed one of the courses you're going to hear about. I've developed and taught many different subjects in the soft computing space at both the undergraduate and postgraduate levels, as well as doing executive training. I do research in the area of cybersecurity management, and if you want to, feel free to add me in LinkedIn by just taking a photo of the QR code. So let's get into this. Firstly, I want to talk about the faculty and the university itself. So the university has multiple campuses in Victoria. The main campus that you can see a photo of here is in Parkville, and that red line that I've just drawn on the screen there sort of shows you the size of the campus compared to the city. It's actually fairly big if you take a look at that sort of photo. And you can see in the campus, you've got most of the teaching is done in this area that I'm sort of circling with my mouse, if you can see it. And then the area that's closest to the foreground is the sporting facilities and the university colleges. So on the campus, there are many innovation precincts, and I'll talk a bit about some of the stuff that the faculty does in a few minutes in those areas. But there's biomedical, there's the ICT area, and so forth. The university itself is ranked number 1 in Australia, number 13 in the world, and number 8 in graduate employability worldwide. In the IT space, the computer science and information systems area is ranked 41 in the world, and the civil and structural ranked 22. World ranking engineering and IT, we're ranked number 50 in the world. Okay, so at the university, if you get those rankings, you're going to have a lot of world-leading researchers, world-leading teachers that are bringing into the teaching some of the things that they're researching. Our courses are accredited through a number of accreditation agencies. In Australia, you've got things like the Australian Computer Society, Engineering Australia, IChemE. There are also non-Australian accreditors such as EURACE and EuroInf, which are European agencies that therefore accredit our engineering and IT courses, so you can actually practice, if you like, in Europe. And of course, if you've got the Engineers Australian accreditation for, say, software engineering, that means you can practice in most of the world, because that's also got the EURACE accreditation. So most of our courses have accreditation of some sort. The Faculty of Engineering IT is probably half of it's based in the building you can see on the screen here, and the rest of it's in the buildings that sort of you can't see is sitting behind there. There are 3 schools. The biggest school is the School of Computing and Information Systems. Then we have the School of Chemical and Biomedical Engineering, which is made of 2 departments, biomedical and chemical. And then you have the School of Electrical, Mechanical and Infrastructure Engineering, which has essentially those three departments, electrical and electronic engineering, infrastructure engineering, and mechanical engineering. In terms of IT, there are a number of those departments and schools that teach IT. The obvious one is CIS, which is computing and IS, but also you can do IT stuff in electrical and also infrastructure engineering, and a little bit of mechanical stuff as well, actually. Let's move on to the IT employment landscape. And in particular, here's some data that we've collected around employment in IT in Australia, I believe. This is done by Deloitte. And as you can see, 2017, 21 and 27, the major employment areas are ICT management operations and ICT technical and professional, and essentially there's growth. And this is what the graph's showing. The table's growing. On average, is about 5.5% growth in the IT space, in digital and IT at the moment. In addition to having growth, the corporate sector's got high demand for IT skills at the moment. And if you look at the salary growth, salaries are actually going up in terms of the IT area. Average tech salaries, as this quote says, spiked 13.9% in 2023. So we have, not only have we got high demand, and increasingly high demand, we've also got high salaries because of that high demand, very likely. So that's sort of the background to IT in a nutshell. The question you've probably got is, how do you study IT with us? And there's a whole bunch here that go through at most of our postgraduate IT programs. But initially, I'd like to start off with the undergraduate, so you can get a picture of Melbourne. So Melbourne University operates under a model where there's a 3-year undergraduate degree, and then that undergraduate degree either leads to employment or it leads to a postgraduate degree. Now, in the IT space, we teach into two main areas, the Bachelor of Science and the Bachelor of Design, but we also teach what they call breadth subjects, which is IT as breadth, and a Diploma of Computing. In the Bachelor of Science, we have 3 majors, so Computing and Software Systems, Mechatronics, and Digital Infrastructure Engineering that have an IT bent. And in the Bachelor of Design, we also have the 2 of those same 3, but we also have this user experience design. So that all leads to employment, or, as I said before, to a master's level number of degrees. So in the Master of Engineering, there is a Master of Mechatronics, a Master of Software Engineering, a Master of Digital Infrastructure Engineering. We have a Master of Information Systems, a Master of Information Technology that has specializations in AI, computing, security, digital innovation, distributed computing, and human-computer interaction. We have a Master of Computer Science, which is more of a researchy type degree where half of your degree is research. And then we have other things that are taught elsewhere in the university that we may or may not teach into, including the Master of Data Science and the Master of Business Analytics. Okay, that's a snapshot of what the university does. Okay. Let's move on now to just an overview of IT. So as we know, IT is everywhere. It's ubiquitous. It's being dealt with in every single industry that we have. The event of AI, understanding, how things are working, underpins scientific discoveries, medical breakthroughs. It's central to what we do. Okay, so everything that we're doing these days is around the IT space. IT's in everything. But the IT space, for me, and this is my opinion, is a continuum. Okay, it ranges at one end from electrical engineering, which is, how do I design the computers that we're using, all the way through to commerce, which is really how I'm using those computers in business. But in that continuum, we have computer science, which is more the algorithmic thinking. We've got information technology, which is programming and development as such. software engineering, which is the same as IT, but a much bigger range and complexity. We have information systems, which is really about how do I make use of computing in organizations and society. Then we have other things like data science, which is half maths, half IT, and understanding how the IT can use the mathematics to do analytics of some sort, and understanding how that works across multiple different disciplines, ranging from science all the way through to commerce. User experience design, which is really about the front end of computing. So how do we make the front end of the computing stuff better in terms of the user, in terms of improving their experience in interfacing with the technology that we've got. And then finally, we've got digital infrastructure engineering, which is really about infrastructures that are using the IT from an engineering focus. And I'll go through all of these in detail in the next few slides. So I should point out, going from electrical to commerce is going from very, very highly technical to non-technical in terms of the computer information technology. That's what the continuum is looking at. So if I look at our first IT sort of degree, which is I'm starting from computer science and going towards the right, computer science has a focus which is primary on theoretical and mathematical aspects of computing. It looks at data structures and algorithms. It looks at programming languages and really the fundamental stuff about how does computing work, okay? Courses in computer science have topics like data structures, algorithms, programming, theory of computation, software development, AI. They're focusing, and in our particular case, the computer science degree has 1 year of coursework and then 1 year of research. Now, in terms of career path, the computer science career path is really, you go into software development, data science, computer science, researchers, and they are focusing on solving complex computational problems and developing new algorithms. So that's probably the most technical of our degrees. The second degree, as we keep moving towards the right of that diagram, is the information technology degree. So information technology degrees are a little bit more practical and hands-on than computer science, and they're focusing on the management and implementation of technology and systems. The core subjects are very similar to computer science, but you might have additional things like system administration, hardware maintenance, database management, cybersecurity. For information technology, the career paths here are more, I want to be a network administrator, a system administrator, an IT support specialist. You might want to become a cybersecurity analyst or a technology consultant. And they're really responsible for managing and maintaining an organization's technical infrastructure. Okay. Moving across again to software engineering, the focus of software engineering is around the practical application of the engineering principles of software development. Okay. It emphasizes software design, development methodologies, and project management. So the way that I think about software engineering is they're similar to the IT people, but they're focusing on much bigger systems, and they need to be able to manage the projects that are required to develop these big systems. So core subjects in this degree would be things like software design, software development methodologies, software testing, project management, quality assurance. And they're still going to be doing things from the computer science side, which is the programming, the algorithms type stuff. And they're going to be moving into the what I call is the more project management information system side of things as well. So it's sort of an overall sort of umbrella for these types of students in these degrees. Career paths here are things like you want to be a software developer, a software engineer, a quality assurance engineer, even a project manager. And the idea of this sort of career is that they're focusing on building and maintaining software systems efficiently and reliably. Moving further right to the information systems area, information systems is designed really to bridge the gap between the IT people and how IT people speak about their stuff and the commerce people and how commerce people speak about their area. And the idea is that information systems people know a little bit about the computing, a little bit about commerce, and they can bring the two sides together to bridge that gap. They emphasize use technology to solve business problems, societal problems, to manage information, and also to support decision-making processes, much like a data science analytics type focus. The core subjects here might include database management, business analysis, system analysis and design, IT project management, information security. There may or may not be programming. In our course, there is some programming. And graduates of IS tend to work as business analysts, system analysts, IT consultants, and again, project managers. And the idea is that they're helping organizations and society to leverage technology to improve things that are going on. So in a business, that'll be their operations and decision-making. Now we sort of get out of the main core of what we do, but we also have some other degrees you might be interested in. And I notice one of the questions here is about data science already. So data science is interdisciplinary. You've got around about half of data science is the computing stuff. The other half is the mathematic stuff. And then the other half, if I can have three halves, is actually the domain-specific knowledge that you need to apply your data science focus to. So when we're teaching data science, we'll have, half the subjects will be maths, half the subjects will be computer science, but then you'll be asked to probably do things in different domains so you understand different domains and how you can actually use the data in those domains in data science to produce outputs. Some of the topics that they will cover here are things like data cleaning, data analysis, machine learning, statistic modeling, data visualization, and this whole idea of big data. Okay. Now, the data scientists become a data scientist. They might become an analytics person working in the analytics field in a business. They could be, working in analytics or data science for an art museum who are analysing things like paintings, even. So the idea of the data scientist is to use data to help organisations, governments, etc., make data-driven decisions, to build predictive models, and to solve complex problems in various industries. In practice, probably in all industries, depending on what you want to specialise in. Digital infrastructure engineering, here, the focus here is on, location-aware services, virtual environments, becoming experts in a range of civil areas such as construction, smart cities, smart vehicles, energy and water. Okay, the core topics here are going to be infrastructure and digital infrastructure, so understanding what infrastructure there is in engineering, understanding things like transport, sustainability, data analytics, how can I use IT to manage cities and so forth. But they're also going to do things like project management and entrepreneurship, which are more in the business or the softer IT area. So they have a range of skills here. The key to the digital infrastructure engineering degree is that they're looking at things like smart cities. The students who are doing this degree will end up usually in an engineering type job, but they might also work in some sort of IT job as well. Then we go on to the user experience, or HCI as it has been called previously. And it's all about how people interact with technologies. Okay, it's the design of technology to enable a person who needs to interact with a technology to better interact with that technology, hopefully in a seamless way. Okay. An example that I've always been told, and it doesn't need to be technology, it could be, think of something like a door. If you've got a door that's the push door, why have you got a handle when you have to, that suggests you're going to pull it? So it's about design. It's about using good design techniques to reduce the amount of thinking that a user needs to have when they're trying to interact with an IT artifact or a technology artifact. The core subjects that students may do would include human-centered design, user evaluation, design thinking, social computing, information architecture, and flow. And the jobs range from a huge variety of jobs around the user interaction area. So it could be user designer, interaction designer. It could be, a human-centered computer person and so forth. There's a lot of different types of jobs in this area as well. That's the main set of degrees we have. However, there are other areas in which we dabble inside those degrees. Okay, so you can have, in both the Master of IT and Master of IS degrees, there is cybersecurity and information security. There'll be an online degree in cybersecurity coming from the university in about 6 months. There's AI across most of those degrees we talked about. We've got health informatics and information systems in our IS area. We've got bioinformatics and biometrics. We have ethics, including cyber ethics, data ethics, privacy, personal security as well in some of our subjects. And we have smart cities, which is a fairly large area in the digital infrastructure engineering space. So they're the courses that we offer, and I hope I'm giving you some ideas of the different careers that you can get from different courses, because they are slightly different, and there is overlap, and it really depends on how technical on that continuum, how technical versus non-technical you want to be in your career. Some of the outcomes of our degrees can be seen with some of our alumni, and I'll just shoot through 4 or 5 slides of alumni. So Andy Sum, during his Master of Software Engineering, wrote a bit of software on the iPhone called Crossy Road, and they're working on different games now. So he was a graduate of the Master of Software Engineering in 2015. Kate Lucas is a person who did the Master of Information Systems. She graduated in 2014. So these are students who have been out in the workforce for 5 or 6 years, 10 years, this one. And she is actually the Chief Analytics Officer for the Victorian Agency for Health Information. Okay, so she would have learned some analytics in the MIS to get to that location. Anna Lee completed her Master of IS again in 2010. Did some subjects in the HCI space in that Masters, and now she's the user interaction research lead for Zendesk in Singapore. Okay, and the final one to look at is Jack Zhang. So Jack did his Master of Computer Science back in 2007. He's the co-founder and CEO of Airwallex, which is an $8 billion company that we interact with at the university. So I've got really 1 or 2 more slides to go. The key to all of this is employability. Okay, so when you're starting to think about the degree that you're choosing, you need to think about, okay, and I'll say this, it's the same thing your parents have told you for 20 years. What do you want to be when you grow up? Okay, so that focus on selecting the right degree to get where you want to be, but there's also a whole pile of employability factors that can influence that. So firstly, the technical and content competence. You need to show employers that you have that. How do you do that? Well, doing well in a good degree that you've chosen. Okay, you need to show employers that you've got confidence and adaptability. Okay, and you gain confidence and adaptability through practice and networking outside your comfort zone. If you don't like presenting, go and present a lot. If you don't like talking to people, go and network and talk to people a lot. Get out of your zone to develop that confidence and adaptability. You need to show employers that you have communication, collaboration, and persuasion skills. Okay, because most employers and most jobs you get, those are three things that you need to be able to do. And to do that, you can improve your language skills, and you can actually gain team building skills in the course that you're actually studying. Understanding knowledge of culture and emotional intelligence. Okay, so being aware that there are different cultures, different cultural norms, being aware of how to talk to people in certain ways depending on what's going on, having that emotional intelligence in that way. I mean, you get that through, interacting across different cultures, understanding different cultures, and of course through social networking. And then finally, really, here is having knowledge of the industry that you are going to work in. Okay, so if you're going to work in the mining industry, you need to actually understand the mining industry. And you can do that on your own and in some of the subjects, because some of the subjects will have these examples. You can research on and network with industry people from that industry. And there are opportunities at the university to do this industry networking. Okay. And finally, understanding employer expectations. Okay. You need to know what the employers want at the start. Okay. So one way of doing that is, again, is just networking with industry, listening to what industry wants. And of course, these days, that means that you need to be able to do all of that remotely as well, not just in person. So being able to sit on Zoom or other social networking or video conferencing and being able to actually show that you can do these things virtually as well as in person. So that concludes my very quick 26-minute go. We're going to open it up for questions now. So if you've got any questions, either put them in the chat or feel free to ask. So as the questions come in, I will go back and I'll try and answer some of these. And Danielle, feel free if you wanted to jump in. What's the difference between a Bachelor of Science and Bachelor of Design for software engineering? Okay, so if I go back to that slide, if I can work out how to do it in a hurry, which is back down here somewhere. Where are you? There it is. So there's computing and software systems in both of the degrees. What's the difference? The difference is what subjects that you do outside the computing and software systems major. Okay, so in the Bachelor of Science, you have to do science-focused subjects. So that might be maths, it could be more software systems, it could be chemistry. Whereas in the Bachelor of Design, you're doing architecture/design type subjects. Okay, so it's a different focus for those other subjects. Okay. The second question is, can the Master of Data Science be completed in 1 year? It'll be shorter if you've got more knowledge in either of the two sections, as Danielle has said. Okay, would a diploma in computing taken concurrently with an undergraduate degree qualify me for a master's in data science? Danielle, I'm going to have to ask you for that one. I can't remember the data science masters as much as I should. It should get you into the data science because you've got some background in the IT space, is my answer.
Yes, but you would also need to have the mathematics. So
Yeah.
it's important to understand that for the Master of Data Science, you need to have a major in either programming, computer science or mathematics, and some subjects in the other discipline. So you need to have a background in both. So for example, if you had a major in computer science, you would also need to have at least a couple of subjects in maths, and vice versa. If you have a major in maths, you need to have at least a couple of subjects in programming or computer science. So the diploma of computing would definitely satisfy the computing aspect, but you'd also need to have the maths.
And we've run out of questions. So we'll give people a couple of seconds to add questions if they need to. Is there anything that we haven't said that you want us to say? That's the question that you need to ask. Is it clear around the differences between the degrees. That's the main thing. Okay. Waiting. Yep.
I have some question about the popularity of the program for the master degree. Is it harder to get into Master of Data Science as opposed to applying to Master of Information Technology?
Would you like me to take that one, Sean?
You can take it. I can answer it. I can say it's the same hardness.
It's the same, yeah. Yeah, all of these degrees at the moment are very, very popular and very high demand. So every intake, we need to, balance. We have so many applications that are actually qualified and meet the minimum. So with all of these courses, we have to rank the students and only make a certain amount of offers to those top students. So they're all really competitive at the moment because they're just so popular. Everybody wants to do the IT courses.
Yes. Okay.
So it will vary from semester to semester, really, in terms of, the higher grades, for which course, just depending on the cohort that applies in that semester.
So look,
yeah,
part of my advice here, right, and I'm going to be very cheeky here and say, apply for digital infrastructure. Okay, because that's a lower, it's not as popular as some of the others. Right? So you can actually then do some of the stuff that you do in some of the other degrees as specializations in that degree.
Okay. And the way the admission look at the application, so the student with higher GPA will be accepted faster. That's how it works. Or the faculty wait until all the applications the deadlines close and then start to assess. So how does it work?
We are assessing them on a rolling basis. We have only just commenced in the last few weeks to look at semester 2 intake because we've been busy with start year. But we do make some rolling offers as we're assessing for very, very high achieving students. But we put the rest on hold and we look at them when we're closer to having assessed everybody. So we are aiming to, because we've closed those courses quite early to give us time to get the offers out. We have closed the courses as of the 31st of January. So we are hoping that we can get all the offers out by end of April at the very latest. But yes, I mean, it's a combination. So we are sending some out as we go. But the bulk of them, we are going to waitlist them and then be able to say, okay, we can make 100 offers now, and that'll be to the top 100 students. So yeah, it's a bit of a mix.
Okay, so basically, if they want to get the student who got higher grade and submit the application early will be accepted sooner. So
yes, but it's very high at the moment because we have to be really cautious for mid-year, because we've actually gone a little bit over in start year. So we basically work it out. We say, okay, normally if we make this many offers, this many people will enroll, and this is how many places we have. But actually for start year, we've had an amazingly high acceptance rate of offers. So we've already gone over our caps. So we'll probably be making even fewer offers into the mid-year intake at this stage. So we're being very, very cautious and we're only sending really extremely high marks, like equivalent of about 90%. So we're really only sending offers to those really, really high achieving students at the moment.
Okay. And I have another question. For a student who got a little bit lower GPA with work experience, does it help with the experience with the lower GPA? But of course, they still meet the requirement. Do you think the admission look at more on the GPA or also work experience?
No, we don't really. It doesn't really offset a lower GPA. The only time we're looking at work experience is if they're applying for one of the shorter programs. So with Master of Information Technology or Master of Information Systems, if they have an appropriate undergraduate degree and relevant work experience, they can have a shorter program, like 1 year or 1.5 years instead of 2 years. So that's the only time we're really looking at work experience, but we don't use it to offset GPA.
ค่ะ โอเคค่ะ Thank you very much. That's very clear. Yeah. I think we have another question.
Yeah, I
Yep,
guess
that's just
yours.
about data science. No, Master of Data Science only has a start year intake, so they don't have a mid-year intake. So the next available intake is start year 2026.
เลยค่ะไม่ทราบมีใครมีคำถามอื่นไหมคะ I'm just checking if anyone else got any question.
Feel free to come on, put your video on and ask in person. It's a nice small group.
ดีไหมคะOkay. I think if I'm checking if we do not have any more ถ้าเกิดเราไม่มีแล้วเดี๋ยวเราก็จะจบเซสชันของเราแล้วนะคะถ้าเราไม่มีคำถามอื่น
Just popped an email in the chat. That's our admissions coursework admissions team. So if you have further questions, you can email them and ask them some questions if it's about admissions into the programs.
Thank you so much, Sean and Danielle, for the session today. ก็สำหรับ we really appreciate your time. We know the time difference, and it's probably already 5 o'clock.
Okay.
Okay. Thank
Just
you.
a few minutes past.
ขอบคุณมากนะคะนักเรียนทุกคนนะคะถ้าใครสนใจศึกษาต่อ University of Melbourne นะคะสามารถติดต่อ Education for Life ได้นะคะเราเป็นตัวแทนที่รับการแต่งตั้งอย่างเป็นทางการนะคะแล้วก็บริการฟรีค่ะ Thank you very much สำหรับทุกคนนะคะแล้วก็ Thank you Daniel and Sean I think it's good for today Okay just gonna wrap
Thank you.
Thank you
Thank you.
Bye bye